Dear students, now we are going to learn about teaching of geometry, especially the theorems to the students in mathematics. We know that teaching of geometry develops thinking and reasoning powers among the students. Right methods of learning geometry definitely improves their thinking and reasoning powers. Then, how to teach theorems in mathematics? Let us see with an example. Let me take a simple theorem. That is, if a perpendicular is drawn from the center of the circle to its chord, it bisects the chord. You might have studied it in your school, right? So, what is the theorem? If a perpendicular is drawn from the center of the circle to its chord, it bisects the chord. So, let me convert the given statement into the figural form. So, if a perpendicular, this is the center of the circle, O is the origin of the circle, this is AB is the chord of the circle. If a perpendicular is drawn from the center of the circle to its chord, then it bisects the chord. So usually what happens in sometimes what we observe, after giving the statement of the theorem to the students, the teacher draws the figure on the board and then the steps follows like this. Given, what is given? AB is the chord and OM is perpendicular to AB. And what is to be proved? To prove, what is that we have to prove? To prove that AM is equal to MB. Then automatically the next step follows, that is construction. What is the construction? We say join OA and OB. And next step, automatically it is the proof. What are the steps in the proof? In triangle OAM and OMB, we equate both the triangles and OA is equal to OB, OM is common, OM equal to OM, common in both the triangles, and these two angles are right angles, that is angle OMA is equal to angle OMB is equal to 90 degrees. This is what, and hence the proof. This is what we observe. But if we adopt this method for teaching this theorem, at every step students find it very difficult. They come across number of doubts. The theorem is about if a perpendicular is drawn from the center of the circle to its chord, it bisects the chord. And the teacher draws the figure like this. Now the question is whether the figure should be drawn as it is like this, or can any changes be made in this figure, is a big question. Next, for construction, here OA and OB are joined. Now there is a big question to the student. Whether OA OB only have to be joined, why not we go for some other points, taking some other points on the circumference of the circle and join this? Why this particular construction is so important, relevant? And then, coming to the proof, why we need to compare these two triangles? Why only triangles have to be formed through in the form of construction? Why these two triangles to be compared? And why the particular procedure for proving the theorem? All these are doubts in the minds of the students. Instead, if we can help the students to decide the appropriate figure for proving the theorem on their own, and how to help the students to decide the required construction for proving the theorem, and how to help the students to give the logic behind the proof. Is it possible? Then which is the suitable method to help the students to prove the theorem on their own, apply their logic and reasoning while proceeding from step to the next step? That is what is called analytic method of teaching, or analytic synthetic methods of teaching. That's why we always need to adopt analytic synthetic methods of teaching, particularly while teaching theorems in geometry. That helps students to